We have 5 main types of reactions that we're going to look at. The first is synthesis, and then composition, single replacement, double replacement, and combustion. We're going to look at each of these individually, both with a definition, a general reaction, and then a specific reaction involving certain chemicals. So our first one is synthesis. A synthesis reaction is defined as the combination of 2 or more elements or compounds into something more complex. So this is actually one of the simpler types of reactions. So we have A plus B going to AB. So A and B are most likely 2 different elements. They could also be an element in a molecule, could be all sorts of things. But they're combining together to make one complex thing. So in our example, we have solid iron reacting with oxygen from the air to make iron oxide, which is rust. It's balanced, so we have 4 irons, 3 oxygen molecules. It's O2 because it's a diatomic. Gives us 2 iron 3 oxide, iron 3 oxides. Our second reaction type is decomposition. Decomposition is simply the reverse of synthesis. Synthesis is putting together, decomposition is breaking apart. So a complex molecule breaks apart into its simpler components. So in this case, we have AB breaking apart into A plus B. Our example is water. So we have water that breaks apart into its hydrogen gas component and its oxygen gas component. It's balanced, so we have 4 hydrogens, 2 oxygens, and 2 oxygens on both sides. Our next type of reaction is the single replacement. In the single replacement, we're focusing on charges and not just combining or separating different elements. So one element trades places with another in a compound. So in general, we have element A combining or reacting with compound BC. A trades places with B, so we get compound AC, and we get B left over. So in this case, A would be positive, B would be positive. Our positives are going to switch spots, and then C would be negative and it would stay. Our example, we have zinc reacting with hydrochloric acid, and we get zinc chloride and hydrogen gas. So in this case, our zinc replaced our hydrogen. So they're both positives, and our zinc replaced our hydrogen to get zinc chloride on this side. It's still balanced, so we have 1 zinc, 2 hydrogens, 2 chlorines, 2 chlorines, 2 hydrogens. Our fourth reaction is a double replacement. So this is where the cations and the anions, both the positives and the negatives, are going to switch spots from 2 different compounds to make 2 entirely new compounds. So we have compound AB reacting with compound CD to get BC and AD. So in this case, A and C are our positives, B and D would be our negatives. So B is going to combine with C, which is the other positive, and the other positive. A is going to combine with D, so that we have a positive and negative over here. It's a little confusing in general terms, so let's look at a specific reaction. We have lead 2 nitrate reacting with potassium iodide. Lead we know is a metal, it has a positive charge. Nitrate is a polyatomic ion, it has a negative charge. Potassium has a positive, it's a metal. Iodine has a negative, it's a nonmetal. So our 2 positives are going to switch places. So our lead and our potassium are going to swap. So our lead is going to go with our iodine to make lead 2 iodide, and our potassium is going to go with our nitrate to make potassium nitrate. So all they've done is recombine themselves with their other corresponding ion. Our last reaction type is combustion, and we're going to look at combustion of organic compounds, which means compounds containing hydrogen and carbon. We're going to look at oxygen combining with those compounds to always form CO2, or carbon dioxide, and water. So we have methane as our example, CH4, combining with O2 oxygen from the air to make carbon dioxide and water. You will always see an organic compound reacting with oxygen to produce carbon dioxide and water, as long as it's an organic compound, which are the ones that you'll see in this class. So it's still balanced, 1 carbon, 4 oxygens, 2 oxygens here, 2 oxygens here, 4 hydrogens, and 4 hydrogens.